Hello to all the aspiring students of data science. Today we are here for a career counseling session with an expert from the industry who has more than 1.5 decades of experience in data science. So we have Mr. Vishal Agarwal here with us. Sir is graduated from the IIM prestigious institute and has done his bachelor's from the IIT. Sir has more than a decade experience as Senior Director of Cognizant and is currently the partner in Ernst & Young. So welcome Vishalji as an expert.
Yeah, thank you. Thank you.
So sir, here we are going to be discussing about data science, not from the corporate perspective, but from the perspective of students who have just passed out class 12th. That what kind of scope that is there in data science if they choose it as a career, because recently the university has introduced computer science and data science as a specialization. So if I talk about data science with an example, can you please give the students a brief overview of exactly what data science is?
Yeah, sure. Data science is all over the news right now, right? Everywhere you hear about analytics and data science, and you'll hear a lot of projections about how this is, the career of the future, and how there'll be a huge growth of this in time to come, right? And we already have seen that coming, and if and there are various terms to that, right? Somebody talks about data science, somebody talks about artificial intelligence, somebody talks about machine learning. They are, more or less the same thing, right? It's just a different way of talking about data science, but they are all, almost the same thing from a career perspective. And if you really look at the way the industry is really headed, it definitely is really poised for a huge boom, right? Since 5-6 years now, there have been a lot of people who are actually taking up data science. It started off with mostly banking companies, banking organizations in more mature markets like US and Europe who are doing a lot of data science. But now you see almost each and every company doing data science or analytics in their business, right? And if you look at analytics, like where do we not have analytics, right? If you see, for example, uh, to take some examples from different industries, like when you enter a large retail store, right, you'll find that if you enter a store like say More or Walmart or something, if in another country, you'll find there's a particular set of way things are organized. You'll find that for example, at the checkout counter, you'll find a lot of knickknacks like chocolates or toffees or stuff like that. When you go to aisles, you'll see a specific arrangement of items, right? That is not random. It is not somebody's just put it like that, right? All of it has a deep science behind it. A lot of mathematics goes into it, right? For example, data has shown that if you have say chocolates or bubble gums or those sort of things near the checkout counters, the propensity, these items have a high impulse buy, right? So the propensity to buy them increases dramatically, right? Then there's a very famous example. You probably have heard about it, the beer and diaper story, right? Sometimes I think in the early 2000s, people found that there was a high correlation between beer and diapers, right? When people are buying, right? Though they seem to be very different categories, but when people found that when people buy beer or when people buy a diaper, they have a higher propensity of buying the other one as well, right? And placing them together increase the sale by almost 35%. Again, this was not a random study. It was based on a huge amount of analytics which goes behind it, or in other words, data science, right? Similarly, if you are browsing a website, right, you browse a website and you suddenly see a lot of ads coming to you. If you look at your mother or your friend or father, if you're browsing the same website, you will find different ads popping up there.
All right. Thank you. So as Vishalji has said that these are synonyms, I mean in terms of the industry perspective, machine learning, AI and data science. Now, sir, you have had significant years of experience in the industry, both from the software side and from the data analytics side. I would request you to, from a fresher's perspective, as if I'm a fresher and I'm willing to enter into computer science engineering, would you suggest me to take computer science engineering as a generic field, or maybe go for a specialization in computer science engineering in data science?
So, no, I wouldn't, sort of, it's again, it depends a lot on the individual's, what he really likes, right? It depends on that a lot. Both of them, computer science also is a very hot field, right? More and more advancements are going to are coming, and they're going to continue coming in computer science as well, right? Programming, even in the hardware space, right? We are talking about, faster and faster computers, ability to process millions of, terabytes of data in, in seconds or milliseconds and all that. So that itself is a huge field, right? Which requires a lot of work to be done, a lot of new discoveries to be made, a lot of new inventions to be made, a lot of things to be done, right? So computer science by itself also is, I wouldn't say that it's something which is dying away. It is definitely growing and will continue to grow, right? Just like data science. Get up the infrastructure ready, right? So like I talked about, big data technologies. How do I process petabytes of data? How do I ingest data in real time from millions of sensors, right? It could be sensor from a traffic light, or from a watch, or from a temperature sensor. How can I ingest that in real time, and how can I make it available for analysis, right? All those come under the domain of computer science, and also a lot of those things, right? Whereas if you look at data science focuses a lot more on the application of that, right? Once I have a lot of the data, with solve business problems, right? So and I gave some examples of that, right? So once I have my, for example, computer science will enable me to, if I talk about, take the example of self-driving cars, right? Self-driving cars requires the car itself has 15 to 16 different sensors or cameras on the car. I think somewhere between 13 to 15 cameras on the car, right? Thousands from which it infrastructure, a lot of that, really comes in computer science or big data technologies. But once I have all the data, how do I actually write an algorithm which actually processes all that data and enables me to actually drive that car, right? That is where data science actually comes to play, right? So both are equally important. Now it depends on what is a person's particular more and more advances in computer, or is he looking at more into the data science space, where apart from programming knowledge, so if I talk about the skill, programming knowledge is important, but also ability to understand data, process the data, and generate business sites. That's also a key skill which a data scientist should have, right? And again, it's an individual choice, but I think both career tracks.
So that answers, thank you, sir. That answers another question of students, that what is basically the difference between big data and data analytics. So data analytics is derivation of the information basically from the huge amount of data that has been collected and processed.
Right. Yeah, exactly. So data science, I would say, sits on top of big data. So if I do not have the ability to process large amounts of data, I'll not really be able to do data analytics, right? I would say big data is the enabling infrastructure, right? It helps in setting up those, big Hadoop stacks, or on the cloud environments and stuff like that, which enables me to process these millions of data coming from multiple sources in real time. And once it's there, then data science sort of takes over and generates insights which drive the business decisions.
True. So one more question. Because it requires huge amount of logic and analytics, do you think that a student should have strong mathematics skills to take admissions into the data science field?
Yes, I would say that no, not necessarily maths per se, but statistics is something which is definitely important, right? I think that goes without saying that if you do not understand the stats, the model you'll build will not be optimal. You'll not really understand what those models really mean, right? Because at the end of the day, if you program well or write a program, it will throw you some output, right? Now, whether that output is really valid or not, does it really is it statistically significant or not? Can you make any inference from it or not? That you'll only be able to say if you really understand the stat behind it, right? So I would say not probably the entire maths. You probably don't need to be an expert in say differential or the algebra or trigonometry and all that. Maybe you don't need that, but you definitely need to understand stats very, very well. I think that is one of the core requirement for a good data scientist.
Data scientist.
That is true. That is true. And especially for banking applications.
Not only for banking application, any model, because when I make a model, I need to test whether that model makes sense or not, right? And when I say make sense or not, make means from a mathematical point of view, does it, or from a statistical point of view, I should say, does it make sense or not? It can show something, right? But it may not hold. If I give it another set of data or a random set of data, that model may say something else, right? So the only way I can say that the model is really robust. So when you must have heard the word, I have built a very robust model, or my accuracy of my model is 90% or 95%, right? Those are all statistical terms, right? So until you understand what a 95% confidence model means, or when you understand that whether this model is significant or not, or what is the t-test or p-test, you'll not really be able to say that this data actually means this, despite what your algorithm is saying, right? So I would say yes, stats is definitely very, very important for anybody who's aspiring to be a data scientist.
Data scientist.
Point taken, students. If you're choosing data science, then your statistical understanding of the numbers has to be good. Another question, sir. Now you have been sending requirements to the markets for recruitment of freshers in this field of data science, and you've been a strong member of the group who controls data science. So, sir, a question that what do you see are the projected numbers in terms of the requirements that are there for freshers to be joining this particular field? And if I say that the degree of computer science, basic computer science, or with a degree of computer science with a specialization in data science, would it make any difference for the choice of the candidate that you would probably interview?
Yeah. So second question first. So if you look at the requirements of data scientists, the key skill sets of a data, I would say there are three main things which are required. I already talked about stats, so a good knowledge of stats is definitely important, right? Second, he needs to have good programming skills, right? And again, it can be any programming skill, because the language keeps on changing. While if you're doing software programming, people typically start with C, C++, or something like that, right? The language over here is different, right? The typical language is say Python, R, or if you're talking about big data, Scala, right? So those are the languages. But anyway, that's not important at this stage, right? You need to know some language, because once you know some language, right, how to code, what is the logic of writing a code, right? Then picking up new language is not so difficult, right? So some amount of programming basics is required. You don't have to be an expert programmer for a data scientist role, because the good thing about data science is that there are a lot of libraries which are available, right? If you talk about Python, you have NumPy, Pandas, a lot of libraries where you have ready-made codes available, right? But even how to use that code, you need some amount of programming, right? So that's the second skill, I would say. Apart from stats, you need stats first. You need programming. The third thing, which is very important, is you need to have some amount of business understanding, right? Because a data scientist is not, especially when I talk about when we are hiring, we don't typically hire a person who's just a statistician, right? For example, there are a lot of institutes which have a course on pure stats, right? Again, while I said that stats is an important criteria for data scientists, it is not the only criteria, right? In fact, somebody who understands the data, the meaning of the data is also very important. In fact, I would say that is one of the core skills, right? Because finally, as a data scientist, you are trying to solve a business problem, right? You're typically data scientist not for the sake of data. You're trying to solve a business problem, so you need to know what data, what the insight to be explained in terms of the retail business, or if I'm doing it for a banking industry, it needs to understand the nuance of the industry. What does that various characteristics domain? Knowledge. I would say, that's still not months, 3 months, a very rigorous training in which they will, whatever gaps they feel are there in that person, they will try to, sort of bring him up to speed, right? But that is true for very, very large companies which hire, say, data scientists in bulk, right? But then there are also smaller companies which are looking at, say, just recruiting, 4 or 5 data scientists, or maximum 10 data scientists for a particular year, right? Those companies may not have the required infrastructure or training curriculum to really train people from scratch, right? So for them, they would prefer people who are more who have already done some already know some data science, right?
Question probably from the experiential perspective, if you've been given a project which your team has solved, so in that how the data is collected from the logs or from whatever way the data is being stored from the generic company's operations. So how the data is being collected, how the data is being processed, who processes the data, then who analyzes information out of it, who makes business decisions. So what are the different roles in the data analytics field? And then do you hire fresher for each of the separate different roles, or there is one role that a fresher has been hired at and then he is promoted from one role to the other, or so on and so forth?
Right. I think that's a good question. Again, I would say that typically, again, okay, so I'll not, so let me answer the question in a different way, right? I'll talk about what are the different skill sets required during the course of a project, right? As a project. And then, whether one person does it or 2% does it, we'll debate that later on, right? So to your point, to a question, Vihang, right? So the first data, right, into some stack, right? It could be a data lake, it could be a data warehouse, it could be a big data stack, it could be various things, right? And the type of data which you're ingesting, it could be data which is from a customer's CRM system. It could be from the transaction system like SAP or Oracle or something like that. It could be unstructured data which is coming from say social media like Twitter, Facebook, or blogs. It could be data coming in from sensors or logs from your factory. So there could be multiple types of data which is coming, right? Again, some data is monthly, some data is weekly, some data is on a millisecond basis, if it's real-time data. Some data comes in flat files. So various types of data which is coming in, right? So the first thing before you even do that, and again, the important thing is you just don't start collecting all the data and dumping it together, right? First, you need to see what is the business problem you're trying to solve, right? For that business problem, what is the type of data do you require, right? So if for example, I'm trying to solve a sales and marketing problem, I probably do not need the sensor data, right? So no point in trying to dump all the sensor data from a manufacturing plant into my data warehouse for this particular problem, right? So first you understand what is the business problem I'm trying to solve. For that business problem, what type of data do I need? The first role over here is basically a role of a data analyst, right? Who basically discusses with the client, understands the business problem, understands what he wants, and then he also has an understanding of what data is required, and then he sort of creates that, okay, this is the type of business problem we're trying to solve, and these are the data streams which we want, right? So that is, he'll create a, that role will involve understanding the business problem and creating what is the data set which I really require, right? That's the first role. Second role is, once I have identified my data roles, I then create a platform where I can ingest the data, and which I can, like I said, it could be a data warehouse, it could be a data lake, it could be a big data stack, it could be on premise, it could be on the cloud, depending on what the client's preference is. There could be various options, right? So this is where the role of a big data engineer comes in, right? He basically is the architect who understands what is the amount of data, what is most appropriate for this level of activity, right? In terms of frequency, velocity, the four V's of big data, right? Velocity, veracity, velocity, veracity, volume, and variety, right? So based on that, he'll create a big data, or it could be a data warehouse as well. He creates that data structure and a data platform in which the data can be ingested. For ingestion, there are multiple tools, ETL tools, which are available out there. This is secondly for data architect, or we can also call him a data engineer, who basically create the shifts to the role of a data scientist, right? Where generate insight for that, right? I think it could be, very descriptive in nature, where you're just trying to see what happened, why did it happen. Be predictive, where you're trying to predict what it could also, which is more advanced, where you're trying to say, okay, if this has happened, this is what you need to do, right? So for various things, you would write different types of algorithms and stuff like that. Again, not going into as simple as it could, who does that, right? The fourth role sometimes is where you have a visualization, right? So now you have, algorithms run, you have the output ready. Now, how do I actually present it in a dashboard, or in a report, or a summary, or a review, which the management can, sort of access on a, on-call basis or whatever, right? That's where the visualization expert comes in, right? Where again, there are a number of open source and industry tools which are used. For example, Tableau, ClickView, ClickSense, or 4J or whatever, right? Depending on that thing, he creates those visualizations or inside dashboards, which are then presented to the client for the action, right? And obviously, throughout this process, you have the business consultant who is basically involved at each stage, and really interacts with the client, and fills in whatever gaps, and then explains those models to the client as well, right? So once you're done with the models, you can't present a mathematical model to a client, right? You need to convert that into a business sense, right? So typically at that time, the data science needs to wear a hat of a business consultant or a business analyst, who then explains what those model means and what is the recommendation of those models, right? So this is the sort of chronology of a typical data science project, and I mentioned what are the various skill sets required at each stage, right? Now, to your question, whether these are different people or the same people, again, it depends on the type of organization which you're joining, right? If it's a very, very large project which you're working on, right, there typically you would have different people doing different things. So you would have a team which is doing the business analyst role, a team which is doing the big data, team which is experts in data science and all that. And then these people become specialists over a period of time. They become specialists in their area, so they become very, very deep in those areas, right? And so a person over a period of time, he'll be able to do a big data, for example, project stack for any type of problem, and he'll be an expert in that area. Same thing with the data scientist, right? Another way is with the one person who does sort of the entire life cycle of the project. If because a lot of data scientist projects are start by 2 or 3 people only. They're not like a software project where you have hundreds of people working on it, right? In that case, the same data scientist, a team of 2 or 3 people, would typically do all those steps, at different points of time in the project life cycle, right? In that case, they sort of go through the entire journey of a project. They may not be experts in a data lake creation or whatever, but they know enough to actually, do the end-to-end project and deliver it, right? So again, it depends on context, depending.
That is true. That is true. So that has been a very amazing and explanative answer, students. You might want to, I would summarize so that you can understand this process. Coming from an expert, it would be a little difficult for you to understand the various stages. So what sir said is basically there's a role of the analyst to understand from the customer that what are his requirements, and then the data is collected. The data is stored in the form of various tables wherein part of big data comes in, and then certain operations are done upon the data that is stored in by the data engineer, who actually perform certain algorithms, and then based upon those algorithms data visualization is done. Once the data visualization is done by tools like Tableau or something, and then finally the role of a data analyst comes in, who actually creates business decisions out of it. So that is a complete flow, and if you are joining, it need not necessarily be you have to be specific for a particular role. You can do maybe few 2 or 3 roles or all the roles at a time. This was an amazing explanation, Vishalji, and believe us that students all over the country are going to be benefiting with this. Another question, sir, is like, since you mentioned in the starting that there are certain ads that follow students when they visit internet, or certain activities that they're getting logged. So what is the difference between web data analytics? I mean, what do you give us some knowledge about web data analytics? What is that?
So, web data analytics, I would say it's of data analytics, right? So if we talk about data analytics, that's the larger pie. Within that, web analytics is a type of analytics which focuses on WebEx, right? So in WebExes, typically you look at things like like I said, who's visiting your website, who's buying, who when you visit website, what page does he look at, right? So they are something called heat spots, right? So they actually measure where did you where did you roam the cursor the most, right? Did you scroll down or not on that web page, right? Where were your eyes focused on most? So they create a hotspot which actually track that, right? So that's one thing. They also track how did you reach, for example, it's a website of say Amazon, right? Now how did you reach that Amazon page? Was it because you saw an ad in some other website, right? Or did you come through Google? Did you come through a third party? Did you get a link on a mobile website which you clicked and then you came here? So the traffic of how you reach that stage is also very important, right? Things like also then that how much time did you spend on that website? What is your if you get a link, what is your open rate, click rate, buy rate? Those are various metrics which they actually measure, right? The reason so what they basically do is in web analytics, they focus on all the data which is available when you are browsing their history, right? Again, the objective is more or less the same, right? Or I would say the objective of any analytics is the same. They're trying to solve a business problem. So in web analytics, the problem they're trying to solve is for to their websites, right? Once you're there, they want you to maximize the amount of time you spend there. They want to maximize the amount of purchasing you're doing from their website, right? So those are metrics, right? And for that, basically, you rely on this website data. Like I said, how did you come to this website? Once you understand that, then you will understand where should I spend my money on advertising. Should I spend it on a banner on Google? Should I spend it on on a banner on say Netflix? So you watch Netflix a lot. Should I any ad on Netflix? You have a higher percentage to click there. Should I spend it there? So that is one part. Second part, like I said, is how should my website be designed? Where are your eyeballs focused on, right? So they have that heat maps which actually see if for example the purchase button is down below, they may find that the propensity to buy actually decreases if it's not in front of your eyes, right? So a lot of that thing of how to design my website, how to do all those things, are taken by are done by in the web analytics space, right? So it's I would say, it's like I said, it's a subset of data analytics, just is that it's focused on web traffic. And now since a lot of things are digital, so there's a huge importance, there's a huge importance for web analytics, which is growing day by day, right? Where people are really looking at how can I maximize each and every dollar which I spend on web analytics. So in fact, a lot of companies are now diverting a lot of their spend, say from TV or other media to web, because the number of people, the amount of time people are spending on the web is increasing exponentially, right? So if people are spending more and more time on the web, that means their propensity to buy from the web is also increasing, and that's why analytics for web to understand the behavior and to offer them the next best offer is also increasing, and that's where web analytics is becoming very important. But in short, it's still a part of data analytics, right? It's just a subset of data analytics. There are some different techniques which are used, but more or less the it's still the same thing. The same, you're trying to identify the customer behavior.
Great, sir. Great. Two last questions. I have been asking a lot of questions from you, I believe. I understand it is a Monday, it's a working day. Sir, one second last question is, there have been a lot of discussion upon data mining. So how does data mining fit into play in the entire picture of data science?
So data mining per se, it's not different from any data analytics, right? So what do we do in data analytics, right? In data analytics, once I have all my data, I try to find hidden patterns in that data, right? So I write algorithms which find out hidden patterns. So this thing has happened in the past, and what is the probability that it will happen next, right? That's what I typically try to do in data science environment, right? So when I'm sort of searching through my data, when I'm looking for those hidden patterns, that itself is called data mining, right? So it's just I would say it's not very different. It's just a step in the entire data science process, where data mining is one of the steps where I'm looking for those hidden patterns.
All right, great. And one last question, sir. In the period of lockdown, do you think that the requirement for data analytics has increased, or data science has increased, or post the period of COVID, do you think that this industry is going to have any recession, or there are going to be more requirements or more job opportunities for students?
And all that. So in the short term, yes, there's definitely going to be an impact in all sectors, in all hirings, including data science hirings also. There will be some impact, right? So again, I'm being very honest. It's not, I don't want to say, no, data science is going to be perfectly okay and all that. There's definitely going to be an impact, right? But the impact on data science will be much lower than in other areas, right? Why? Because now, since that, people are working from home, the amount of data which is generated today is actually gone up significantly compared to pre-COVID, right? And I'll give you some examples, right? For example, in the pre-COVID times, a lot of salesmen used to go out in the field and take orders, right? So all those kirana stores which you have, so there would be a salesman from each company who would go around, take orders on a paper, and then those orders would be fulfilled, right? uh, a lot of that was on a paper trail, right? So what was ordered, what was delivered was not really captured in a system, right? Now because of COVID, a lot of that, almost the entire order taking has moved online. So whether it's overnight, companies have deployed apps, mobile applications, or whatever, to actually reach out and those orders. So because of COVID, what has really happened is that overnight, a lot of the data which was not captured digitally has actually converted and been captured digitally, right? A lot of, for example, trucks have sensors now. People have deployed sensors to actually track where the truck is or the ship consignment is, because each consignment is very critical for them, right? So overnight, again, supply chain area also, we see a lot of digitization of data which has suddenly happened, right? So because digitization of data has happened, that means now the quality of insights which data science can actually bring is actually going to increase significantly, right? So while in the short term, there definitely is an impact in all sectors, and data science will also be impacted to some extent. But overall, I think data science is actually going to go stronger because the amount of data now out there is much, right? And the amount of insights is also much more. And also companies will now are post COVID, they'll look for more significant insights of how they can make an impact on their business with a small investment, right? And I think their data science is really going to play an important role. So so again, to summarize, in the immediate term, there's going to be an impact everywhere. But I think 2 quarters down the line, I think data science is going to see the strongest recovery, and the demand for data scientists will be much more than what we.
Thank you. Thank you. Sir, we would be very, very thankful from all the students' side and from the institute side, from the education fraternity, being so busy that you have given so much of time and have answered most of the questions that could arise in the field of data science. Students,
My pleasure. Thank you.
thank you. We are very lucky to have Mr. Vishal Agarwal answering all our questions. Thank you. Thank you, sir.
Thank you.